So how are you guys? You good? So my name is Christopher Maronga, and I work at Chem Welcome Trust as a data manager. So prior to this, I have sent an email with some file. I don't know whether some blank files, some R code. How many have received? Nice. Who hasn't? Because we are going to, this session is going to, I'm going to try to be hands-on practical on what you're going to do. And by the end of the session, you're going to fill that blank template with the codes of your own as you're going to proceed forward. So make sure you have this code with you because you're going to type codes. Okay? Okay, so I'm going to take you through data structures. And I know by now you've really learned about vectors, so you know how to create a vector. You know types of vectors, the integer, the character, the logical, and the double. So, so in this session, we are going to expand our knowledge on further objects in R. So apart from vectors, we have other objects in R. So some of them are called factors. We have matrices, we have lists, we have arrays, and the most fundamental one, which is called the data frame. So we are going to work with these types of objects, create them, operate on them, and actually see how it can help us in our future engagement with R. Okay, so those are the other types of objects I'm going to cover in this session. So you've done vectors, so you know how to create a vector. You've used the assignment operator. And you can create a vector using the C, which we call combine or concatenate, isn't it? Yeah. So you just take things, combine together using the C to form a vector, either numeric or character. So now we are going to go through the same process, creating these other types of objects, factors, matrices. Of course, we are going to vary a little bit of functions in creating some of those objects. But the idea is the same. You are trying to combine things together to make an object that you can work with in R. So now, I'm introducing a function there, str, that is short form for structure. So given a vector, or rather given an object in R, so when you use that function on that object, it should print out the structure of the object, whether it is a vector or a factor or something, and even give you more information about the object within. So without wasting time, I'm going to jump into factors. So what is a factor? So I know you've looked at a character. So you took some elements or other names, of course used some quotation marks to combine and form a vector, character vector. So a factor, I will term it as a special type of a vector, character vector, that is used to store categorical data. So a categorical data is a data that has limited or rather limited values. For instance, let's talk about level of education. So you can be in high school, primary, university, college. So you can define those particular values. So that's what we call a factor. So it doesn't matter how many times those values appear in your data set. They are only the unique ones. So that's a factor. So it's different from a character because a character can take any value within the range. So we create a vector using the function factor. Of course, we are going to see some of the arguments. So some of the arguments that the function takes is a vector. So the vector is an element. Those elements you want to arrange. For instance, I have a vector of maybe gender, male, female, male, female, male, female. So that's the elements I'm talking about. So when I arrange those, I'll form a factor of only male, male, female, because that particular vector takes distinct values or rather options. So we have levels, we're going to talk about them. But I want to jump to the structure down there. So that's the syntax of creating a factor. Just say factor, open the parentheses, input the elements you want to arrange, Then you define your level. So the levels are the unique values that are allowed for that particular arrangement or that particular array of a vector. So for instance, if I'm talking about male, female, male, female, male, female, so the levels for my vector, or rather for my factor, is male and female. And we set them using the argument level. So I want us to define a few terms here before we go to creating factors on our R console. So open that script, you're going to use it. So when you talk about factors, now that I'm talking about distinct values, so we have two types of factors. We have a nominal factor, or rather nominal categorical variable, and ordinal. So for the statistician inside here, you know what that means, isn't it? So the elementary statistics. So nominal meaning, yes, it's a factor, but doesn't have any ordering. So there is no level that is better than the other. So male, female. So there is no. But if you're talking about low, high, medium, so there is some kind of ordering, natural ordering. So that's what we talk about. That's what we term as ordinal. So it has a natural ordering. So because this is what you're going to do in the code, I'm just going to jump straight to that particular scheme. So I want us to create. So assuming. So I want us to say, for instance, let's classify the levels of Nairobi temperature. I know temperature is a big topic in Nairobi right now. So let's talk about temperature. So the classification may be high, low, medium, and the sort. So I want you to refer to this vector here. So I want us to create a vector and call it Nairobi temp. So just a normal character vector. So remember, a character vector, when you create a character vector, the name you use inside the combined function, which we call it the element of our vector, you have to enclose it with a double quotation mark or single. So let's get going. So I want you to start coding this. So create a vector. So we are calling that vector Nairobi temp. So the temperature in Nairobi. So I'm using the assignment operator. Hello?
Yes.
Hello? Are we creating that vector? So I'm using the concatenation function, or rather the combined function. So and I want to throw in the classification of temperature. So I have that. So I have low, low, medium, high, low, and medium. So can you create that?
If you need help, just call.
Yeah, if you
Just raise your hand, yeah. Then we'll come.
At least I want everyone to create this vector, because we are going to use that vector to create a factor. So a few seconds left, then we move on.
Perfect time. Are you halfway through or you're just starting?
Who is stuck? So I'm going to run this code. So to run a code in R Studio, there are several ways. So one, you can highlight the entire code, then go up here on the run button, then hit the run. Or the same procedure, but just make sure the cursor is anywhere between n and the last bracket. It will still work. So just click the run, and it will run. So those who love shortcuts, you just put your cursor anywhere in between the line, then you hit Control Enter. It will run the code. So I'll use Control Enter most of the time. So you'll see I'm running codes, and I'm not highlighting. But for you, just pick a method that works for you. So I have run that code. You can see on my environment on the left here, I have an object which is called Nairobi temp. So I want us to, I hope I'm not too fast. I want us to print the Nairobi temp. So I just want to run this on the console and look at what print. So we have, it repeats the same elements in the vector. That is low, low, medium, high, low, medium. So I don't want to stop there. I want to use what Keegan in the last session taught you, how to find the type of an object by using the function type of. So I'm going to use type of to actually ascertain what type of an object is Nairobi temp. And you can see it's a character. It's a character vector. So now, at this point in time, I want us to convert the Nairobi temp character vector into a factor. So we are not ordering anything right now because I want to clearly explain or rather differentiate between the two, nominal and ordinal. So those who have the script, so the instruction is here. So this is how I want us to proceed. So after we create any object, even the list or matrix, I want us to print it first, then use structure on it, and there may be type of. So if I forget any, kindly remind me. So it's important. We print it, we use structure. We want to see the structure of the object. Then finally, we do what? We use the type of to know what the type of an object it is, right? Okay, so type of Nairobi temp, that's a character vector. Now I want to use the Nairobi temp, which is a vector, to create a factor using the function factor. And I want to save the resulting factor into an object called temp underscore factor. So let's do the code. So the name of the object is temp underscore factor. Who has created the factor object? And tell us. So if you have created the factor object, I want you to do type of temp factor and tell us what kind of so I'm typing this to give you time to convert that to a factor. Okay, how many have done it? Factor. Who has a factor already created? Okay, so what is the type of the temp factor? Integer. Good. A very good point. Anyone else who is observing the same? Great, now I can create it. So we said we create a factor using the function factor. So I'm going to create temp factor here using assignment operator. Then I'm going to type factor. So the first argument of factor, the first argument of the factor function is what you want to convert into a factor. So in this case is what? It's Nairobi temp, right? So I just want to type Nairobi temp there. Then run that. Okay? So running type of factor, I'm getting a rather non-usual type, integer. So who can guess why I'm getting type of factor as an integer? Hello? Anyone? I know we have advanced R users inside here. Please be part of us. Help us get others starting or other running. So why is a factor an integer type?
Mike.
You said factor assigns levels. So what that function did, it assigned dummy variables to the factors. So like low was probably given 0, medium was given 1, and then high was given 2. So that's an integer, a whole number.
Bingo. That's right. So a factor sometimes is confusing. It stores both. It stores levels, and as such, it contains both integer and some character labels within it. So usually, the type of a factor is an integer, just because it has levels, because it has to arrange. Even if it is nominal, it has to arrange because it will collapse. So it has, I'll just scroll up, it has low, medium, high, low, medium. So it has to collapse and assign levels to each of the unique, making it an integer. So let's proceed. So the structure of a factor, the temp factor here, you can see it's a factor with how many levels? 3 levels. So at this point in time, when you don't supply the levels you want, or rather when you don't name levels explicitly, what R does, it takes your vector, then it arranges them alphabetically. So for instance, now here, so low, medium, high, I don't know what, between L, M, and H, what comes first? So it starts with H, then M, then L. But that's not what you want, isn't it? You want low, medium, and high, right? So we are going to see how we can command the function factor to arrange the levels for us the way you want it. Because temperature cannot be high, medium, low. It is low, medium, high. So those are the levels. So let's get going. Before that, I want us to print a summary of the Nairobi vector and the temp factor using the function summary. So the function summary prints out some statistical summaries on an object. So if it is a categorical or if it's a factor, it will do what we call counts. So now, let's do, this one I'll do for you. So let's do summary on Nairobi vector, Nairobi temperature, sorry, and do summary for the temp. And I hope you know now the difference between the two objects. So one is a character vector, the other one is a factor. So let's print the summary and see how they behave, both of them. Do they behave the same way? Okay, so I'll do this. I'll run this command summary. So you see, it's the summary of a vector gives you the following. It gives you the length. So the length is the number of elements in a vector. So I have low, low, medium, high, something. So I have 6 elements. So that's what the length tells me. Then class, it is to what data type is that particular object belonging. It is character. So class and mode. So, but if I do summary for temp factor, look at what I get. I get a summary of how many highs, how many lows, and how many mediums I have. So the difference between a factor, and this is very important when you'll be working with R in the future, when you're doing your modeling, you realize that it's very important for you to have, if you are doing classification, to have your outcome variable as a factor. Because if you have as a character, you end up interpreting wrong things.
Just to add on to that, something I've realized is that imagine you have data that is like monthly data, right? You want to plot maybe, I don't know, amount of rainfall. You want a graph of amount of rainfall per month. So on the y-axis, you'll have average amount rainfall, right? Then on the x-axis, we have months. So what R does, if you fail to convert variables to factors, it arranges them in alphabetical order. So when you see your graph, the first month will be April. Then after that, like ideally you want Jan, Feb, March up to December. But then if you don't change it to factors, it will arrange them in alphabetical order. So that's why factoring is really important. Even sometimes when you have such a graph of low, medium, high, you want low at the beginning and high at the end. So this is really important.
Thank you, Shel. So now, so we talked about what R does, arranging by alphabetical order, but that's not what you want. So in this next exercise or other thing you want to do, so you want to set these levels ourselves. So you want to define, you want to say the first one should be low, the next one should be medium, and the last one should be high. So you do that using this argument that we call levels. So I'm saying levels, they are a unique set of allowed values in the in the vector. So you pick out the unique set, then define your hierarchy, how they are arranged, then do what? Supply to the level argument. So we are going to do it this way. So maybe before I do it, can someone try? So we are going to name it, of course, still it's going to be temp factor. But remember, we are going to use the original vector, which is Nairobi temperature. So factor, we are calling factor on Nairobi temperature. But this time we want to set level. So when you are having multiple arguments in a function, you separate them using a comma. So like you see the first command we just did factor Nairobi temperature. But this time around we are including extra functions, the likes of levels and all those. So when you want to add another argument to a function, you just separate them using a comma, then you continue typing. So the good thing with RStudio, if that argument is available in that function, it auto-completes for you. So you just hit enter, then define your levels. So let's define our levels as vectors. So we are using the combine function again here. So we are combining low, medium, and high. And we are supplying that vector to Nairobi, to temp factor, sorry, as its level. So I'm going to do this. So levels, concatenate, or rather combine. I know so I want to have my lowest ranked temperature category to be low. So it starts from low to high. So if you are doing something else, for instance, you wanted to arrange a couple of things, maybe like she said, you wanted to arrange months of the year. So January, February, March, April. So you start with January, then February, then March, April, like that until December. That way you tell R that my lowest ranking level is the one that appears to the left. Then the others follow. So I'm going to do low, medium, and finally high. And I'm running that particular factor. So if I print it out, like we said, so we create an object, we look at the structure, then we print it out to see how it behaves. So I'm going to do temp factor for me to print it out. So I don't know if you can remember how the other one arranged for us. So okay, so there's a very interesting behavior here. So you remember how the other one printed the outcome here, the output here. This one is now telling us that yes, you have a factor containing low, low, medium, but you have the levels as low, medium, and high. So I'm having my levels here. So I know now if I do a plot on this particular vector, my low will be on the left, medium in the middle, and high on the right. So I have arranged, or rather I've added arguments to this particular factor. So the other thing, yes, yeah, this is important. R is case sensitive. It is case sensitive. So temp factor and the temp factor, those are two different objects. So if you created this factor as small t, then you want to use it as capital T, it doesn't exist. Okay? So it's case sensitive. Capital R, small r, are two different. So sometimes I feel like factors are so much ignored when it comes to handling them. And trust me, in most of, majorly about over 85% of the statistical analysis that happen, they utilize factors as the outcome. For example, you want to do classification, prediction, so it's factors. So the moment you don't get it right, you fail to interpret. So should I proceed now?
Yes. Any more patients who need help? Raise your hand. Don't feel... Okay, I think you're good.
Okay, so now I want us to bring in the aspect of now ordering. Yes, I know low is low, low is low, medium is medium, and high is high. But I want to tell R that that's the case. I want you to order, like I want to tell it, can you order it that low takes the least, medium takes the medium, like the way it's medium, and then the highest takes. So for instance, now I want to do something here that I'll be able to explain later. So if I compare low, I want to extract the element of the factor low. So I want to compare low and high using the logic operators that Keegan taught you in the previous session and see what happens. Then after that, we create an ordered, then we do the same comparison and see if something are different. So because we want to see, does telling R to order things make the object a bit different, or rather behave differently? Okay, so I'm going to extract temp factor. So don't worry, you will learn this, how to extract an element from an object, the way I'm doing it here. So what I'm doing now, I am singling out the low, and I want to compare it to high. So high is maybe number, so maybe number 3 or something. Sorry, so I just want to call factor. So I want to compare medium, which is number 1, and low, which is number 2, by using the, so you see it's telling me it's false or something. Maybe it has ordered or something. So maybe I should call ordered is equals to false to see, because usually when you have an unordered factor, when you try to compare the two levels, you get an error because it doesn't know. It doesn't know how to compare something that is not having some ordering. So let's try and order our temp factor here. Even though I know it has ordered before me telling it, I think the default is true. Yeah. Maybe I can say false. So let's introduce a third argument to the function factor, which is called ordered. This one here. So we had how many arguments? 1, 2, 3, 4. Vector, whatever you want to convert into a factor. Levels, the unique allowed values. Labels. So these labels are names. For instance, if I don't want to use low, medium, and high, I want to use L, H, and M. So you do that using labels, because you are putting labels to levels. So I want to use, instead of having low, I want to use the first letter L. So you'll do that the same way I did for levels, you do for labels. Then I was talking about this one here. Ordered is a logical, either true or false. So if the ordered argument is true, R will order the levels in an ascending order, the way you provide it. If it is false, it won't order. Let's change the labels first before we could do some ordering. So suppose you wanted to use L for low, M for medium, and H for high. So I want you to use the argument labels within the factor. So expand on the code on line 17, but now add the argument labels. So change low to L. Okay, like this. So allow me to copy, but you don't copy. You should type it so that you can. Let me copy because of time, but for you, you should type it. Because the more you type it, the more it gets into your blood. Instead of having my levels as low, medium, and high, I want to change them using labels. So I want to use different labels. So you do the same thing. Use a vector, use the concatenation function, or rather combined function, then put in whatever you want to use as labels. So in this case, I really want to use L for low, M for medium, and H for high. So if I run this particular code, you realize that I'll have a factor which doesn't have low, medium, and high anymore, but you'll have LL, HM, HL, because I have changed the labels. This is important when you have data that is coded in the levels that you don't really want to use. For instance, you have maybe, I like using gender. You have gender which some has capital F, some female, capital F, female, small f, capital M, male, but they are still M. So if you order them, it will start with M. So if you really want to sanitize such a kind of a data set, so you can define your own labels. So you say, whatever is being occupied by female, let's take F, and the male in that order. So have you succeeded labeling? So when you label, I want you to run the code, then please print out the temp factor. Let's see what that contains. And try to relate to the original vector, the original factor. So you realize now I have a smaller output. L, L, M, H. So low, low, medium, high, low, medium. And the levels are L, M, H. So I just want to mention that whatever we are doing today, whatever Keegan covered and whatever I'm covering today, if I finish to the end, it forms the basic for you to start using R, because R is an object-oriented programming language, so it deals with objects. So when it comes to a data set, for example, you have a data set that you collected somewhere using Excel and you are reading it to R, so it will store it as an object. So the moment you know how to manipulate some of the objects, extract things from them, then you'll be able to use it correctly. So this is really a foundation for you to continue using R effectively. Okay, so anything you type after a hash sign is a comment. So R does not run that. Like this one here. These are all comments. So when you use hash, then you type something, it will be ignored by R. R will not execute that. It will see it as a comment, so it will ignore it. So if, for instance, if I do a hash before this command here, that won't be executed because that now turns into a comment rather than a code. So if you want to talk to yourself, your future you, because some of the things Keegan outlined is that reproducibility is very key. So you might be doing some analysis, you want to do it later on, 5 years from now. So the best thing to do is write what? Write comments. Talk to yourself in the future. So when you go to that script in the future, you look at it, you know what you are doing. Okay, let's proceed. So I want us to do the last thing about factors. We want to order. So let's use the order function to actually order this particular factor. So I will be very comfortable using the original vector without labels of L and M, ordering the factors, the factor object. Okay. Okay, so I think I have it copied. I'll paste, but for you, you should type it, please. So I'm not going to use labels because you have seen how it works. I'm now going to use ordered. So these are the function. This one here. So I'm going to say true. Ordered equals true. So it's a logical. Either false or true. Okay, so I'm going to do this. So when you are specifying a logical operator, like true and false, you can either type true in full or just use T. It's the same. So I can just use T and it will work, or I can just type true. Yeah, so I can type true entirely, or I can use the first letter, but capital. So let's run and see what happens. So temp factor, we said we had rules for operating here. We said once we create an object, we type it, we print it. So when we want to print an object, we just call it on the console and run it. Just run the code. Okay. Now look at that now. Look at the extra things that are coming in between the levels. What does they tell you? What does those things imply? Hey. Someone, what does this imply? Because we have ordered. You said do this, levels ordered is equals to true. You remember the initial one did not have those kind of items. I just scroll up. Yeah, this one did not have those arrow-like things. So what does it tell you? Anyone from the, anyone to try?
I promise you, whatever you're thinking is the right answer.
Anyone try?
It has
put them in a setting order with loading loads, and it gets to you that graph the loads and the first.
Perfect. So I have ordered. Ordered is equal to true. So it's telling me that low is the lowest rank, medium in that order. So high is greater than medium, medium is greater than low in that order. So the same way to any other. Yes, a question or you need assistance? So that is it with the factors. Any other question before we move to the next item? You have any question on how to create a factor, how to pass arguments, how to specify levels, and how to specify labels? Anyone? So let's look at matrices. So a matrix, singular, is an arrangement of elements of the same data type. And I know Kiken talked about homogeneous. So it's an homogeneous, so it's an arrangement of things of the same data type in rows and columns. So if you have items arranged in rows and columns, you have a matrix per se. Now, so you can see those are this is the function. We create a matrix using the function matrix. So when you call that put elements, then we have the argument by row is equals to true. So meaning I want to arrange my items row-wise. Of course, you can do false. So row-wise means it does the arrangement. The first row finishes, comes the second row like that. If it's false, it does column-wise. So matrix. Okay, now there's a very small data here I was trying to come up with. So we are still talking about temperature. So let's assume this is the track of Nairobi temperature for the past like a week or so. So I have temperature, cloud cover, humidity, and wind speed. Wind speed in kilometers per hour, humidity in percentage, cloud cover in percentage, of course temperature in degrees Celsius. So I want us to use this information and create a matrix out of it. So we said a matrix is arranged. So I want us to arrange this information in rows and columns. So you can see we have days of the week and we have temperature matrix, right? So the easiest way is to start to create vectors. So you can create a vector for temperature. So see the same way now, I'm sure you are very familiar with it. So I'm going to create that. So I'm going to do combine. But I'm going to get my data from this particular slide. So 21, 21, 23, 21, 21, sorry, 23, 19, 20. So that's a vector of a temperature. So we are going to do the vector of cloud cover, which is 34, 42. I'm rushing. You can follow along for 73, 21, 77. Then create a vector of humidity, which is 60, 63, 54, 49, and 68. Finally, wind speed, a vector of 10, 14, 16, 15, 11. So I'm going to run these 4 vectors. I'm going to execute them. So run, 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 run. So I have 4 vectors that I want to arrange. I want to put in a matrix. So I'll either decide I'd rather have the temperature matrix on the to be my rows and the days of the week to be my column. So what you need to understand is that this is the temperature for Monday, Tuesday, Wednesday, Thursday, Friday. This is the wind speed for Monday, Tuesday, Wednesday, Thursday, Friday. So let's use matrix function to create a matrix. So I'm going to do this. So I'm going to call that matrix weather matrix, or rather weather mat. So weather matrix. So I'm going to call the function matrix. So after doing that, I'm going to feed in a vector of the elements I'm going to create the matrix for. So temperature, there is cloud cover, there is humidity, then there is wind speed. Okay. So by row equals to true. So I want matrix to arrange these vectors row-wise. So it puts the temperature, puts cloud cover, puts humidity, then wind speed. Then finally, I will specify how many rows do you think I need? Someone quickly. If I arrange row-wise, how many rows will I need here? Thank you. I'll need 4 rows. So just remember the argument n row. So argument n row is for number of rows. So it's defined number of rows. So then I'll say n row equals to 4. So if I run this and print it on the console, you see what I get? Let me scroll up. I get this. This is a matrix. 4 rows, 5 columns. Okay, I can see, I can try to do a structure on it. It's telling me it's a 2-dimensional object which is numeric, and it has number of rows 4, 1 to 4, then number of columns 1 to 5. Okay, so this is not really useful, knowing that you have Monday, Tuesday, Wednesday, Thursday, Friday as your columns, or rather as the column headers, and you have, is it temperature, cloud cover, humidity, and wind speed as your row. So it makes no sense. So you can rename. So you can, I'm introducing 2 functions here that I'm calling row names and column names. So row names are used to name the rows of a matrix. Column names are used to name the columns of a matrix. So our columns are days of the week: Monday, Tuesday, Wednesday, Thursday, Friday. And our rows, as you can see, they are the temperature matrix: temperature, cloud cover, humidity, and wind speed. So let's create a vector of days of the week. So week, call it weekday. Concatenate, I'll say Monday, Tuesday, so Monday, Tuesday, Wednesday, Thursday, and of course Friday. I hope they are okay. So I'll use that one to name my columns. Then I want to also create a column called weather matrix. So I'll have, the first one is temperature, cloud cover, humidity. Temperature, cloud cover, humidity, and wind speed. I hope you are following along. Wind speed, I hope I'm not too fast. So I'm going to create these 2 vectors, weekday and the weather metric. I've misspelled this, so can just change that and run. Now, let us use row names and column names to name the matrix weather mat. So I'm going to take this particular. So I want to name rows. So I'll use row names in parentheses, put my weather matrix inside there, then assign it to the names I want to be part of the row names, which is what? What are our row names here? Weather matrix, isn't it? This one here. Then run. Let's print that vector and see how it appears now. So work is done halfway. So I know I have now temperature, cloud cover, humidity, wind speed. So I want to leave it to you to do the rest for the columns and use the same. Use call names. Call names, then calling the vector for columns. So the same appearance. Call names, so that eventually you have a vector which is temperature, cloud cover, humidity, wind speed, and Monday, Tuesday, Wednesday, Thursday, and Friday. I'm not really going to do this practically, but I want to mention that when you have a matrix, you can do the following operations on them. And some of the operations on a matrix are element-wise. Like Keegan said, it does element by element. So for instance, if I have this matrix here, so if I happen to multiply weather matrix by 2, it simply means every element inside here is being multiplied by 2. So it does element-wise. If I do division, the same. So if I divide this by 3, every element inside here will be divided by 3. So element-wise operation. So that applies for all these. Addition, subtraction. Of course, for multiplication is scalar multiplication. But if you want to multiply a matrix by a matrix, you know the rules. Row column. So the number of rows on the matrix on the left must be equal to the number of columns on the matrix on the right. If they are not, that product will not happen. But for scalar multiplication, element-wise. Same to division. Scalar division, element-wise. So it takes every element inside the matrix, divides it by 2. So let's try just one. Let's try one. Let me try scalar multiplication. So I have my weather matrix. I want to multiply this by 2. So you see what I get? I get 42, which is 2 times 21. So every element within a matrix, it's being multiplied by 2. So same to division and subtraction. So if you have two matrices of the same order, if you subtract one from the other, it goes element-wise. So the first column, first row, subtract the first column, first row on the other matrix. Great. We are doing good. Arrays, a very fun one. It's like a matrix, but again, it introduces another dimension. It can store things or other lists or other items in more than 2 dimensions. So you have a row, a column, and a third property, or a third item, which is referred to as a dimension. So they are rarely used arrays, but you can create an array using this function, array. So just array, put the elements you want to put in an array, then specify the dimension, row, column, and the dimension. If it's 1 dimensional or if it's 2 dimensional, so it realizes it will print out. So I want you to go and try out. Just take some vector and or rather some item, call array on it, specify number of rows and number of columns, or even run that code on your console and see the printout so that you understand what we mean by a multidimensional data structure. So it's a multidimensional. So we started by 1 dimensional, which is a vector. Then we talked about 2 dimensional, which is a matrix. So an array is a multidimensional, so it can store in more than 2 dimensions. So this is the second last item, lists. So for our lists, because you know how to create a vector and a matrix, I'm not going to spend much time on a list. I just want to give you a scenario of what a list is. So we said a vector is homogeneous. It stores data type of the same type. Come an integer, it's integer. If it is character, it's character. Same to matrix. A matrix will store items of the same data type. If it's integer, it's integer. If it is character, it's character. So a list is opposite of them all. So a list can store anything. It can store integer, it can store vector. So the same way you create a vector, you can do it inside a list. But remember to call the function list. So what it does, it puts everything together under the name mylist. So it's the same as they normally say you cannot mix sheep and goat and get something, right? Yeah, a list does that. So it takes goats, cows, takes gazelle together. But it can allow you to extract later on. So that's what a list is. So you know how to create a vector, you can create one, you can create a matrix, but you can combine all those things inside what you call a list. And you can always get help on how to do a list by doing what? Typing a question mark, then lists. So you get more help on what a list is, how you can create it. Or you can type help, then in brackets list. Those two can assist you, sorry. Okay. I didn't want to call it a day before talking about data frames. This is what I'm going to talk about last, because it is very important. So for those who are coming from other statistical softwares, a data frame is what we call a data set in R. So when you have you are collecting a survey, of course, you see we have dealt with one-dimensional things like a vector concatenating medium, high. So suppose you went to do a survey somewhere. Then, of course, you have questions like gender, are you married, yes, no, so such stuff. So you need to store that data for your own use. And you cannot do it using a list. You cannot do that using a matrix. You cannot do that using a vector. But you can do that using a data frame. So ideally, a data frame is more of a list that contains vectors which are of equal length. So Keegan talked about length, items in a list. So normally a data frame is constructed using the function data.frame. But the argument of a data frame is a named vector. So there's a difference between just a vector and a named vector. So a named vector is a vector that has been assigned to a name, like you are calling something. So a combination of these named vectors, depending on what data you are collecting, inside the function data frame will get your data set. So let's just do one and try to look at some very important functions there. We have head, we have tail, and of course the initial function which we call it str for structure. Okay, so let us refer to the data set for weather, the weather matrix stuff, and let's create a data frame out of it. So, of course, yeah, here. So we had, so I don't know what will be our variables. Of course, our variables will be the temperature matrix, the temperature, humidity, cloud cover, and wind speed, isn't it? Then, of course, our rows will be days, which can be as many as they can, depending on which day you did the track. So let's just create this very quickly. So I'll call it Nairobi dframe. Then I'll use the function data.frame. So inside this function, I'll give arguments in form of named vectors. So I'll say therefore temperature is given by some vector. Will you allow me to go back there and copy the temp vector? Yeah, because of time. So let's just copy this. So, and of course, you're going to alter because they are, so here. But I'm going to change this to equal sign, this to equal sign, to equal sign. And the named vectors, you separate them using a comma. So if you don't, R will complain and it will throw an error. So you won't have your data frame. So I have that, so I'm running that command. And I'm doing type of. So let's see type of. What is the type of Nairobi difframe? Did I use a list? Yeah, you remember me saying that a data frame is a list of equal of vectors of equal length. That's why it's telling me that type of this is a list. So you see, it's telling you this is a data frame with the 5 observations and 4 variables. So if you want to view it, you can always click on the right there, and you have a very nicely arranged way of storing data, the same one you are familiar with in Excel and other statistical packages. So this is what we call a data set in R. So if you hear someone talking about a data frame, they are simply talking about what? A data set. Now finally, look at these two. I know you know about structure now, str. Let's talk about tail. So tail and head are two most important functions that are being used on data frames. So what they do, they print, for example, head prints the first 6, or rather they can be 6, or you can define what you want to see. So if you have a very large data set which has so many observations and so many variables, but you want to see the tip of it, so you just use head. So you say head, put the name of the data frame, then specify how many rows you want to see. If you want to see 1, it will bring you the first row. If you want to see 3, so let's demonstrate that. So I have my data frame, which is called Nairobi DF. So I want to use head on it. So I'll say head. Suppose I want to see the first 2 rows. So I'll say head, Nairobi, data frame, then I'll specify 2. Then you see, it will return the first 2 rows over data frame. So if you don't specify the number of rows to return, it will return, by default I think it is 6. It will give you the first 6 rows. So the same way, if I want to see the last few rows of a data frame, I just type tail, then the name of the data frame, Nairobi data frame, D frame, then you specify how many you want to see. If it is 2, if it's 1, if it's 3, so it will give you the last 3. So this is the last 2, this is the first 2. But of course, I don't know whether it will work, but if you reverse that, if you say -2, it simply means from behind, right? Yes. And I am done.